Hey everybody. I just wanted to go over two concepts with you that are found in the Tuna for Lunch case study that might be helpful to you. One is called bioaccumulation, one is called biomagnification. Now both of these words kind of look similar and they kind of sound similar. So I just wanted to go over with you, tell you the difference between them, and hopefully it'll give you a better understanding of the case study and the questions that are asked of you. So bioaccumulation. Bio, right? We learned that means living. And accumulation, if you think of the word accumulation, it usually means gathering of something. So, right, if I'm accumulating points, I'm gaining points. Biomagnification also has that living, but then magnification is usually when you take something smaller and make it bigger. So we're just going to go through these two words and talk about the difference between them in terms of the case study. All right, so bioaccumulation is the buildup of substances such as pesticides or heavy metals in an organism. All right, in this case study, we're talking about mercury, which is Hg. So Hg would be the mercury, and that's what's building up in the organisms in this case study. All right, so if you look down at the picture, the amount of mercury that goes in is represented by the arrow. This arrow is big, right? So there's a lot of mercury going in. The mercury going out, the arrow is much smaller. So there's more mercury going into the fish than there is mercury going out of the fish. Right? This is the idea behind bioaccumulation. So bioaccumulation occurs when an organism absorbs a substance faster than it excretes it. Right? If I'm taking more mercury in and releasing less, where's my mercury going to end up? It's going to end up here in my fish. Right? And the more that I'm taking in, the less that I'm removing. Over time, I'm going to gain more and more. So the longer that the organism lives, the more mercury that they are going to have in their system. Right? So bioaccumulation results in the organisms having a higher concentration than the surrounding environment. So that means that the fish is going to have more mercury in it than the pond or lake nearby. So the water, the sediment, the fish should end up with the most because it's taking in more than it's releasing, which means it's going to be removed from the environment, put into the fish, right? And since there's not as much coming out, you're going to have a lot more mercury staying inside the fish, meaning that the fish is going to have more. So bioaccumulation refers to the buildup of pesticides or heavy metals in an organism. Right? And if you look at our dot here, over time, it gets bigger and bigger. The dot represents the amount of mercury. So the more time it takes, the more it's going to stay inside the fish. All right? Biomagnification, similar to that. It has to do with the gaining of mercury. However, it happens a little bit different in this example. So an increase in concentration of a pollutant from one link in a food chain to another. Right? So we learned a little bit about ecosystems and food chains and food webs before COVID-19 took over our classroom. So when we think back to food chains or food webs, right, the arrows represent the energy being passed from one organism to another, right? So the energy from this organism, when it is consumed, is going to be passed to this organism. So on and so forth, all the way up the organism's chain. So now you're going to end up with more mercury at the top because the energy is being passed further along, right? So when you think about it, if this organism, right, super small, the bottom of the food chain, the only place that this organism is going to get its mercury is from the environment. So it's either going to get it from the water nearby, it's going to absorb it naturally, could get it from some kelp if this is a primary consumer, right? So it's going to absorb its mercury, right? Then when this organism comes along and eats this one, it's now the mercury from this organism is now going to be inside of this one, giving this organism more mercury than this one. All right, so as you go forward and up the food chain, right, your mercury is going to continually be passed. So from here up to our second organism, up to the third, to the fourth, and then ultimately to us at the top of the food chain. Right? The other thing you have to think about when you're thinking about mercury being passed is that this fish, let's say it's a fish, I'm not sure. Right? Let's say this fish eats this organism here, right? It's not going to just eat one of these. It's probably going to eat multiple, right? So it's going to gain mercury from this, but also from a couple more organisms, right? And the same thing with this fish. It's not going to eat just one. Maybe it does, but most likely it's going to eat 2 or 3, right? So on and so forth up, right? An average person is going to eat multiple fish. Let's say you only eat fish all day, you're still going to at least eat 3 fish, 1 per meal throughout the day, right? And that's 3 a day. So all that mercury that this fish has is now going into you times 3. So as you go up the food chain, you're going to gain more and more mercury, and that's what biomagnification means. So if a substance can biomagnify, meaning that it can go through this process, then animals or predators at the top of the food chain are going to have higher concentrations than animals lower on the food chain, right? Meaning that your human is going to have a lot more mercury than the organisms at the bottom because it's absorbing it from the environment, but it's also absorbing it from the amount of food that it's getting. And each organism, as you go up the food chain, has more mercury than the level below it. Right, so even small concentrations of chemicals in the environment can find their way into organisms in high enough doses to cause problems. Right, so even just having a little bit of mercury, right, is going to have enough of an effect on the organism at the top just because of the toxicity of it. Right, so even just a small amount can cause problems. And as you read in the case study, right, it leads to neurodevelopmental problems in children and in women who are pregnant, causes problems for their children even before they're born, right? It has to do with the development. So even just a little bit of mercury can cause that problem. So I hope this biomagnification versus bioaccumulation kind of helps a little bit. Both of these concepts are required in order to answer some of the questions. So let me know if you have any questions, and I will see you guys soon.